So the first one up here, first thing we have to do is, of course, put in the numbers for the letters. So 3z becomes 3 times 4.2 plus 6m becomes 6 times 2.8 over 2q will become 2 times 1.8. Now I'm going to kind of take some shortcuts with my format here. 3 times 4.2 is 12.6. 6 times 2.8 is, what, 16.8? If I add those together, I get 29.4. On bottom, 2 times 1.8 is 3.6. If I divide those, I get what? 8.6? 9.6? Okay. So 8.936? 16, I'm sorry. 8.16. Does that look right? How many of you got that? At least a few of you, because you were yelling at me. Okay, good. 8.16. And again, it's just order of operations. It's a little more difficult because there's decimals in there, so our mind tends to make it, because it looks more complex, but it really isn't. And just like before, your calculator is able to do this. In a problem like this with the fraction bar, I would once again recommend that you punch the top into the calculator and get an answer, the 29.4. Do the same with the bottom to get the answer, which is the 3.6, and then divide it out. Don't try to put this whole thing with a fraction bar in the calculator, because that fraction bar, there are a few calculators out there that do allow you to enter the fraction bar and put the problem in just like this, but they're way more difficult to use for a lot of other simpler things, so I don't recommend using those. Now for our second problem here, 2.871 to the nearest 16th of an inch. We went over this in class, but there were no problems in the homework on it. But if you recall what we have to do, first of all, the 2 in front of the decimal point does not change. That's going to be 2 whole inches, period. And then the 0.871 has to become a fraction. And we do that by putting it over 1. Perfect. Now the decimal point's still there. It did not go anywhere. And that's usually the mistake that most people make, is they move the decimal point or get rid of the decimal point. It is still there. Right now, this has a denominator of 1. We need it to have a denominator of 16. So how do we get there? Multiply by, perfect. Multiply by 16 on top and bottom. So 1 times 16 gives us 16. 0.871 times 16 gives us 13.936. So that tells us it's between 13/16 and 14/16. Which one is it closer to? The 14/16, which of course will reduce to 7/8. So it's 2 7/8 inches. Anybody get that? Just a couple of you? Okay. That is something that, like I said, was not in the homework, but we did go over in class. Depending on what field you go into, that may or may not be an important calculation for you. If you're in any sort of construction-related fields, that's going to be a very important calculation. Other fields, maybe not quite so much. Yes? Yep, even though I asked the nearest 1/16, you get 14/16, it can reduce to 7/8. 7/8 is still to the nearest 16th, it's just been simplified.
Okay.
I get that question a lot actually on these. It's like, why did you put it as 7/8 when you asked for it to the 16th? Because that is still a 16th, it's just a simpler form of it. Okay then, well, we just as well start in with our new stuff for today. I want to review a little bit .32 times 25.7. Now, before we write this out and do any calculations, how many decimal places are going to be in our answer? 3. Very good. If you had to estimate, just a quick estimate of about how big this answer is going to be, what would you say it's going to be? Well, yeah, 4 times 26. I'd even look at 4 times 25, we all know is what? 100. So both of those numbers, the 4.32 is bigger than 4, 25.7 is bigger than 25. We're expecting an answer slightly bigger than 100 here. So we keep that in mind as we're working on this. Doesn't matter which number we put on top. No. Normally, I always put the one with the most digits on top because it shortens my calculation. Here, they both have the same number of digits, so it really does not matter which one goes on top. So now, as we multiply, I'm going to ignore the decimal point. So 7 times 2, 14, so 4 carry the 1. 7 times 3, 21 plus the 1 is 22, so 2 carry the 2. And 7 times 4, 28 plus 2 is 30, so 0, and then we carry the 3. Now, 2 things are going to happen here. I'm going to put in a 0 as I move over to the next digit. I'm going to put a line up here so I know that those are old carries. So now 5 times 2, 10, so this is 0, carry the 1. 5 times 3, 15 plus 1 is 16, so 6, carry the 1. And 5 times 4, 20 plus 1 is 21, so 1, carry the 2. Once again, I'm moving over. Now down here, what do I have to do? 2 zeros, because I'm 2 places from the end. Put a line up here again just to keep track. 2 times 2, 4. 2 times 3, 6. 2 times 4, 8. That's one of the reasons I put that line there, because I didn't carry anything there. But sometimes it can be confusing when you multiply. Oh, I see a 1 up there, I got to add the 1. No, nope, that was from before. If it's not above the line, it's not current. So anyway, now we will add these columns. 400 is 4. 200 is 2. 064 is 10. So 0 carry the 1. So 1 and 3 is 4, 5, 11. So 1 carry the 1. 1 and 2 is 3 plus 8 is 11. Where does my decimal point have to go? 3 places over. I have 1, 2, 3 decimal places. So I count from the end of the number 1, 2, 3 decimal places. So that's what we said before. We had to have 3 decimal places in our answer. Now, we had also said we're expecting an answer slightly bigger than 100, didn't we? So 11.1024 would not make sense. 1110.24 would also not make sense. So both of those things we did before we even started the problem helped us to make sure we get the decimal point in the right spot. Now I want you guys to try one in your notes. Now before you even start this one, how many decimal places do you think this one should have in it? 3 would be your instinct. Go ahead and do it. And what I want you to do is I want you to first, before you start doing this one out, punch it into your calculator quick. Tell me what your calculator says. $28.71. Very good. We do the 6.38 times 4.5. 28.71. Now, didn't we say we wanted 3 decimal places here? Okay, I want you to do it by hand, and then we'll talk about why this didn't come out to 3 decimal places. I'll give you a second. So when we go to do this one, 5 times 8 is 40, so it's 0 carry the 4. That right there is where our third decimal place went. That's a 0. The calculator automatically drops those last zeros. In a minute, we're going to come back and talk about whether that 0 is important or not. So we carried the 4. 5 times 3, 15 plus 4 is 19. So 19, carry the 1. 6 times 5, 30. So plus 1 is 31. So 1, carry the 3. Put in our 0, put a line up here. So now 4 times 8, 32. So 2, carry the 3. 4 times 3, 12 plus 3 is 15. So 5, carry the 1. And 6 times 4. 24 plus 1 is 5, so 25, carry the 2. And so then we got 0, 11, 7, 8, and 2. And yes, the decimal point does go there. So the question I brought up earlier, is that 0 important? Well, it is obviously right here, because if we didn't have that 0, we wouldn't be able to locate the decimal point. So what we had talked about earlier about counting 1, 2, 3 decimals, and expecting 3 decimal places in the answer wouldn't work if we did it on the calculator. But this is 6 and this is about 5. 6 times 5 is 30. Using that estimate would work. 28 is close to 30, so that does make sense to have 28.71. So we do have to be careful counting those decimal places. I mean, when we're doing it by hand here, we have the zeros there. As long as we don't look at that and say, oh, that's 0, we don't need to write it down, we're still okay. We'll be able to place our decimal point properly. But I do recommend that if you are calculating by hand, you do both of those things. Count the decimal places and do an estimate before you start so that you know that location of the decimal point makes sense when you get done. Dividing, of course, was the one that was way more difficult. If I have something like this. I'm going to have you try that one in your notes first, and then I'll work through it with you. As we go to set this up, what's actually going to go underneath here? .4 is what we're dividing by. That would go outside. This is going to be our 48.376, but it's not going to go in as 48. So we're going 483.76. Why is that? Because the number we're dividing by, we have to get rid of the decimal place. We have to move it over one spot to get rid of it there. We've got to move over one spot here. So what's going to go out here is actually 24. How many of you remember to change that? Okay, I'm going to give you a couple minutes to go from there, see how you do. So what's the first thing I'm going to do here? Well, does 24 go into 4? No, so I leave it blank above the 4. Does 24 go into 48? Okay, how many times? I'm going to try twice. So I'm going to put 2 up there. 24 times 2 is 48, so we subtract to get 0. What's next? We bring down the 3, right? Does 24 go into 3? No. Now here's the part a lot of people forget. We've brought down that 3 before we can do anything else. Before we can bring down any other numbers, we have to account for that digit above the 3. What do we put up there now? Since 24 does not go into 3, this is a 0. It goes in there 0 times. So if they run into that where there's a digit that you can't get into, or even if there was 1 left over, it just happened that 48 minus 48 was 0, but even if there had been 1 left over, 24 wouldn't have gone into 13 either. So it's a 0 up there. Now another thing here, before I can bring down the 7, what do I have to do? I cannot cross the decimal point unless I do something with it. That has to go up behind the 0. Now I can bring down the 7. Does 24 go into 37? Once. That would be 24. That is 13 left over. And I bring down the 6. Does 24 go into 136? I would think so. How many times? Let's try 5. 24 times 5 is 120, which would leave us with 16 left over. How do I know if that's right? How do I know that I didn't need to try 6 there? Well, this 16 is less than 24, isn't it? So I'm good. If that 16 were 24 or larger, that would tell me that I'd have to take it out more than 5 times. I'd have to try a different number up here. Now, am I done? Well, the answer is we don't really know yet, do we? Let's say I want this to the nearest thousandth. Am I done? Right now I'm to the nearest what? Hundredth. I'm actually not even to the nearest hundredth. I'm at the 100th place, but I'm not to the nearest one yet. So I need to add a 0 there and bring it down. After the decimal point, we can add as many zeros as we want to. So 24 into 160 goes, let's try 6 times. 24 times 6 is 144, which means there would be what left over? 16. Now we're at the 1000th up here. Does that mean we're done? Say no. Why did I say no there? Because the teacher said to say no. Well, I do have to add one more 0 and bring it down. 24 into 160 is 6 again. Why did I need that one more digit? Yeah, perfect. I need to know whether this stays a 6 or if I have to round it up to a 7. This next digit tells me whether I leave it as a 6 or round it up. In this case, it goes up to a 7 because this is a 6. It's 5 or higher. In fact, this would be 20.15666666666, right? How would I represent that if I wanted to represent that? Instead of rounding it to 0.157, is there a way I could represent that?
Put a line over the top.
Perfect. And then the line only goes over the 6 because it's the 6 that keeps going. It's the 6 that repeats. What if I have something like 4 to, well, do this. We're going to go back to this. 4 elevenths, and I want to change it into a decimal. Well, all I'm going to do is I'm going to divide. This has become what divided by what? In my division, what goes inside the symbol here if I'm changing 4 elevenths to a decimal? 4 goes inside. The numerator goes inside. The denominator goes outside because we're dividing by the denominator. So now, of course, 11 goes into 4 0 times, right? It doesn't go. So we add a decimal point on the 4. We bring up the decimal point and put a 0 over the 4 because 11 doesn't go into the 4. Now what do? Add a 0 after the decimal point. 11 does go into 40 3 times. 3 times 11 is 33. We subtract. 40 minus 33 gives us 7 left over. We can add another 0 and bring it down. 11 into 70, how many times? 6. 6 times 11 is 66. We subtract. 70 minus 66 is 4. We're going to add another 0 and bring it down. So now 11 into 40 goes how many times? 3, just like I did last time. 3 times 11 is 33. 40 minus 33 is 7. Now at this point, we should see a pattern. I'll put that 0 in there and bring it down, but we should see a pattern going here. 40, 70, 40, 70, right? So 3, 6, 3, 6, 3, 6, 3, 6. It's going to keep going. We're stuck in a loop here. So how would I express that? Well, what digits repeat? 3 and 6. And there are no other digits after the decimal other than those. So it's just 0.36 with a line over both the 3 and the 6. Slightly different would be something like 5/6. If I divide that out, it's going to be 5 divided by 6. Of course, 6 doesn't go into 5, so I put in the 0 in the decimal points. Add a 0 here. 6 goes into 50. How many times? 8. So that'd be 48. We subtract to get 2. Add a 0 and bring it down, so it's 20. 6 goes into 20. How many times? 3. 3 times 6 is 18. We subtract to get 2. Add a 0, bring it down. Well, 6 going into 20 is still going to be 3 times. It's just going to keep going. 3, 3, 3, 3, 3. So how would we express this one? Perfect. 0.83 with a bar above the 3. You do have to be careful with these, because sometimes you get to a point where you decide it's not going to repeat, and it still does. Like this one. Get out of there. 2/7. I want you to try that one in your notes. See if you can get that one to work. I'll do it down here. So the 2 goes inside, 7 outside. Of course, 7 doesn't go into 2, so we add our decimal point and our 0. And then put our 0 after the decimal point. 7 goes into 20. Twice. That's 14. You subtract to get 6. Add another 0 and bring it down. 7 goes into 60. 8 times, that would be 56. We'll subtract to get 4. Add another 0 and bring it down. 7 goes into 40. 5 times, that's 35. Subtract to get 5. Add another 0 and bring it down. 7 goes into 50. 7 times. About this time, you're about ready to give up on it repeating, aren't you? Well, 7 times 7 is 49. Subtract to get 1. Add another 0 and bring it down. That's 10. 7 goes into 10. Once. That's 7. Subtract to get 3. Add another 0 and bring it down. 7 goes into 30. 4 times. 4 times 7 is 28. We subtract to get 2. Now, if you look at that, we started with what? 2, right? So we're back at having a 2. The pattern's going to keep going. Starting with a 2, it's going to keep going the same no matter what. So this is going to be 0.285714, 285714, 285714, so on and so on. So it is 0.2855714. Now there are patterns out there like this that just get excruciatingly long. Dividing by 7, it's a 6-digit pattern. There are worse ones, like dividing by 13. Let's put in like 5/13. Doesn't look like it repeats at all, does it? But you can see there 384615, 3846. It repeats. So that has a 6-digit repeating pattern. Now it could be worse. 6 divided by 13, I believe, is the one that's worse. No, that one's still just a 6-digit. Not the one I'm looking for. There's one of them that when you divide by 13, it ends up being a 12-digit repeating pattern, so it doesn't even fit on the calculator screen. You've got to be careful with them. Anything I do to you on a test or a quiz is only going to be like 3 or 4 digits max that will repeat. Okay, so let's move on to the next step. How do I solve an equation that looks like this? For our last test, we had equations with fractions in them. This time around, we're going to have equations with decimals in them. Where would I start here? Perfect. I'm going to add 8.4 to both sides. So the 8.4 is gone. Here I have the 4.2x still equals, well, 2.1 plus 8.4 is 10.5. Then what will I do? Perfect. Divide by 4.2. X is 10.5 divided by 4.2 is 2.5. It's the exact same steps we would have taken if we'd had something simple like 3x minus 2 equals 19. You would add, then divide. It just looks more complex because we have the decimals in there. So I want you guys to try one here. See how that one comes out. So where do we start here? We subtract the 4.4. So we're left, bless you, we're left with 2.8x here. We subtract 4.4 over here to get 6.4. Then what? We'll divide by the 2.8 to get x is equal to 2.285714286 approximately. Normally, it'll either come out to be an exact decimal. You won't keep going. This is actually rounded off. Or I will tell you to round to a certain number of decimal places. This one, believe it or not, is actually a repeating decimal. Like that. How many of you had that? Or something close to that? Really, really close to that? Cool. So we're getting better. How about if I do something like this? Give that one a shot. See if you can make it work. Okay, so looking at this, where do we start? First thing I see is what? There's an X on each side, which usually means I have to get rid of one of them. So where am I going to start? Which one am I going to get rid of? We get rid of the smaller one, which in this case is the 3.5. It is gone. This is 2.8. What do I have to do on the other side? I have to subtract 3.5 yet. So 4.9x minus 2.5x is 1.4x. I still have the minus 3.4, negative 3.4. Now what? add 3.4. So 2.8 plus 3.4 is 6.2 equals 1.4x. And then divide by 1.4. So we get x equals what? 4.428571 approximately. 143 if you want to keep going. Any questions? Okay, let's look at another example. Just gotta be careful here. We'll do it that way. I want you to try this one and see what you come up with. Okay, so right here, again, we see that the variable appears twice. How do we deal with that in this case? Well, they're both on the same side of the equal sign, so I am just going to combine them. 5.2 and 1.1 is 6.3x plus 7.4 equals 15.5. Now what do I do? Subtract 7.4. So 6.3x equals 8.1. And then divide by 6.3. Gives us that x equals 1.285714286. Any questions? How many of you had that one right? How many of you feel you got a good shot at getting these right if you just had more time? Anybody want to cry and go home? Okay, good. We're not at that point yet. Well, let's go one more step. Oops. No x there, sorry. For that. 3.5 times see what you come up with there. Where do we start? Okay, we have the parentheses, and there's nothing we can do in there. So we're going to multiply by the 3.5. 3.5 times 2.4 is 8 point what? 8.4? Okay, 8.4x. For some reason my mind was thinking it should be something different. You're right. 8.4x. Then we have 3.5 times 3.1, which is, pardon me, 10.5? 8.5, okay. I don't know, I'm not picking up sounds today either. I was noticing it earlier when we were doing a sound check on the system. So now we have 8.4x minus 10.85 equals 15.2. What do we do next? Add the 10.85. So we have 8.4x here. Adding 10.85 over here gives us 26.05. And then divide by 8.4. X equals 3.10119. Normally, I'd usually say to the 100th or 1,000th. So if I said to the 1,000th, what would this one be? 3.101. There we go. How's everybody feeling? Happy, excited about doing these? Okay. Let's go ahead and take our break. It is 9:59, so let's try to come back at 10:09.